What if I told you that the companies building the world's most advanced AI, the ones, literally changing the course of human history, are actually on track to lose billions of dollars this year?
It sounds completely backward, doesn't it? I mean,
Yeah.
we see this massive technological leap, and you just naturally assume there are mountains of cash falling right into the laps of the creators.
Right.
But, well, the reality behind the scenes is much more complicated.
And that is exactly what we are going to unpack today for you. We have a really fascinating stack of sources to go through. We're looking at recent business analysis on the Chinese AI sector, some pretty eye-opening insights from the Black Hat Asia 2026 Cybersecurity Conference, and a breakdown of what the industry is calling the global compute crunch.
Yeah. And basically, our mission for this deep dive is to look past all the shiny hype of the 2026 AI landscape, because the conversation has, completely moved away from what can AI do? That was last year. Today, the only question that matters is, can we actually afford to run it?
Exactly. We want to figure out who is really making the money, how global geopolitics is quietly dictating the technology you use, and why AI safety might become, well, the ultimate casualty in this race.
Definitely.
But before we get into the money, let's talk about the physical limits. Because simply put, the world is running out of processing power. And to understand this, we need to talk about how AI usage is measured, right? They use something called tokens.
Yes. Tokens are the basic metric. Think of them as the fundamental unit of AI thought.
Right, so think of a token like the syllable of a word. Every time the AI reads or writes a syllable, it requires a tiny spark of electricity and, a fraction of processing power.
Exactly.
Now imagine millions of people asking it to process massive documents or write software. Those tiny sparks turn into a massive electrical fire. And between January and March of 2026 alone, global token consumption quadrupled.
Yeah, 4 times the usage in just 3 months.
Yeah.
And a huge driver of that spike was the sudden popularity of AI coding tools. Software developers are now using AI to write and constantly check their code.
So it's a lot more demanding than just asking a chatbot a recipe.
Oh, absolutely. Unlike a human asking a simple question, coding requires an enormous amount of back-and-forth data processing. The AI is constantly reading entire software libraries, so the demand is just astronomical.
But the supply is hitting a brick wall. The major companies are quietly rationing their services. The documents show that Anthropic actually changed their terms of service to deter people from using their models during peak hours.
Right.
Amazon openly admitted they are capping capacity, and OpenAI even completely scrapped an entire video generation project simply because they did not have the computers to run it.
Yeah, that was a big deal.
I mean, if these are the biggest tech companies on Earth, why can't they just, plug in more computers?
Well, because it is not a software problem you can just code your way out of. It is a physical hardware bottleneck.
Yeah.
Building a new data center isn't just about plugging in laptops. It requires highly specialized industrial equipment.
Like what?
We're talking about massive electrical transformers and complex switchgear just to handle the power grid demands. Right now, ordering those physical parts can take anywhere from 2 to 5 years for delivery.
Wow, okay. 2 to 5 years. So the infrastructure just physically cannot keep up with the software, which brings us to this weird financial paradox in the sources. The cost of actually running the AI, what they call inference costs, has dropped tremendously.
Yes, it is 5 to 10 times cheaper than it was a year ago.
Right. But despite things getting cheaper to run, companies like OpenAI and Anthropic are still projected to lose billions. If the people building the AI are losing money, who's actually cashing the checks?
The hardware manufacturers. They hold all the power right now. Let's look at NVIDIA, the company designing the most sought-after AI chips. Their gross profit margins have surged to an unbelievable 75%.
75%? That is wild.
Yeah, they have so much cash flowing in that they are actively buying up the global supply of memory components for the rest of 2026 and into 2027 just to secure their own supply chain in advance.
Wait, let me get this straight. NVIDIA designs the chips, but TSMC, the Taiwanese semiconductor company, is the one that actually physically manufactures almost all of them. The sources say TSMC's margins are over 60%. If TSMC is doing all the actual hard physical labor of making the chips, why is NVIDIA making the 75% profit?
It comes down to the difference between architectural design and manufacturing. Think of NVIDIA as the genius architect who draws the incredibly complex blueprints for a futuristic skyscraper. That blueprint is highly guarded intellectual property.
Okay.
TSMC is the only construction company in the world with the microscopic tools required to actually build that skyscraper. They both have a monopoly in their respective lanes.
And everyone else is just paying them.
Exactly. Meanwhile, the massive tech giants and hyperscalers like Amazon, Google, Microsoft are going to spend over $750 billion on capital expenditures this year alone, mostly just to hand it over to NVIDIA and TSMC.
So, if I'm understanding this, it's basically like a gold rush. The people digging for gold are going bankrupt, paying for the equipment, but the guys selling the shovels and the guys forging the steel are making historic profits.
That is the perfect way to look at it. The shovel sellers own the market right now.
But if the shovel sellers are squeezing them that hard, why can't these brilliant software makers just build their own chips to save money? I mean, they employ the smartest engineers in the world.
Designing custom silicon is incredibly difficult.
Yeah.
And it is a completely different science than writing software. You can't just pivot a software engineer into chip design. It requires mapping out billions of microscopic transistors.
Right. It's actual physics.
Yes. Right now, among the software giants, only Google has managed to create a viable, large-scale alternative to NVIDIA's chips. And here's the kicker: that project started more than a decade ago.
10 years of head start.
Exactly. It is not a quick fix. And even if you manage to design your own chip today, you still have to get in line at TSMC to physically manufacture it, because their process is so advanced that even giant legacy chip makers like Intel and Samsung are struggling to catch up.
Wow.
So in 2026, your biggest competitive advantage isn't having the smartest AI model. It is having a massive bottomless balance sheet so you can buy your way to the front of the hardware line.
Okay, so that makes sense for the Western giants like Microsoft or Google who have that kind of cash. But if they are buying up all the chips and all the manufacturing time, what happens to companies that are locked out of that supply chain?
It gets really tough.
Let's look at the other side of the globe, because geopolitics is directly crashing into this hardware problem. The sources detail a massive squeeze on the Chinese AI sector.
Yeah, this is where state intervention collides with the compute crunch. To understand this, we need to look at April 2026. A Chinese AI startup called DeepSeek released their highly anticipated new model, version 4. Now, for context, their previous model shocked the global industry because it was incredibly cheap to train. It only cost them about $6 million, which is pocket change in the AI world.
And for this new release, they came out swinging. DeepSeek V4 was priced at 1/1000th of the cost of leading American models. But the business analysis shows that when it launched, the market reaction was basically just a shrug. People were not impressed.
No, they weren't.
Why did a model that cheap fail to make waves?
Because the illusion of hyper-efficiency was broken. DeepSeek's new technical paper completely omitted any mention of how much this new model actually cost to build. And analysts noted that 16 months passed between their previous version and this one.
And 16 months is a long time in AI.
Exactly. In the AI world, a 16-month gap implies they were running servers continuously.
Yeah.
It means they had to use vast amounts of processing power. It was not a cheap, quick victory.
And the sources point out exactly why it took so long. Geopolitics. The documents show that the Chinese government pushed DeepSeek to use local, domestically produced chips made by Huawei, rather than relying on the standard American NVIDIA chips.
Yes, and that state-mandated detour was a massive setback for them.
Why did it fail so badly? I mean, a chip is a chip, right?
Right.
Why couldn't the Huawei hardware handle it?
It comes down to how AI is trained. You aren't just using one chip, you're using tens of thousands of them simultaneously. They all have to talk to each other in fractions of a microsecond to share data.
Okay.
This is called interconnect speed. If the domestic Huawei chips have a slower interconnect speed, or if their software ecosystem doesn't perfectly sync up, the entire massive system bottlenecks. The whole cluster slows down to the speed of the weakest link.
Oh, I see.
DeepSeek was eventually forced to abandon the domestic chips and switch back to using NVIDIA hardware anyway. They wasted a massive amount of crucial time and money trying to make the mandated hardware work.
So they take a huge financial hit on hardware. But that is not the only way the state is squeezing these companies. The analysis shows a major domestic hit, too. The Chinese government actively blocked the American giant Meta from acquiring a rising Chinese AI startup called Manus.
Right.
They even barred the Manus founders from leaving the country.
It creates a highly constrained environment. You have intense domestic competition. I mean, companies like ByteDance, the creator of TikTok, have a chatbot called Dola that is absolutely dominating markets in the UK and in Mexico right now.
So they're competing globally.
Yes, the competition is fierce, but the government is actively restricting how these startups can operate, who they can sell to, and what hardware they're supposed to use.
It sounds like trying to build a world-class race car, but the government forces you to use a specific, slower engine and then, locks the garage door so you can't even sell the team when you run out of money.
That's a great analogy. The pressure must be immense.
So if Chinese companies are being squeezed this hard on hardware and business, where do they cut costs?
Well, that leads directly to a very critical turning point. When a company is fighting for survival under both state restrictions and massive compute costs, corners must be cut.
Right, and the data from our sources suggests that the first thing to go is safety testing, which brings us to the security dilemma. We're looking at a terrifying contrast between Western AI safety restraints and the lack of restraints in compute-starved foreign labs.
Yes.
Let's start with the American lab, Anthropic.
So Anthropic recently developed a leading-edge model internally called Mythos. But they made a very public decision not to release it for widespread use. They spent the money to develop it, tested it, and then locked it in the vault. They deemed it simply too dangerous to release.
Let's clarify what dangerous means here, because it is easy to imagine some sci-fi robot takeover. But the sources are talking about digital infrastructure, right?
Correct. Mythos possesses severe, highly advanced hacking capabilities. It is reportedly capable of autonomously finding critical bugs and vulnerabilities in every major operating system and web browser currently in use.
So instead of a human hacker rattling every digital window of a house to see what might be unlocked, this AI is like a master locksmith who already possesses the exact blueprint of the house and just custom cuts a key in seconds.
That is a very accurate way to visualize it.
Yeah.
Human hackers have to manually read through thousands of lines of code to find a tiny mistake they can exploit. AI can scan millions of lines of code instantly, recognize a pattern it has seen in its training data, and immediately write a custom script to break in.
And Anthropic saw that capability and chose to hold it back. But then you look at the white paper for DeepSeek's new V4 model, the company that was squeezed by hardware costs and government mandates.
Yeah.
Their technical documents completely omit any mention of safety guardrails or protective testing, like none at all.
And you have to view this lack of safety through the lens of what is actually happening on the ground in cybersecurity. The Black Hat Asia Conference in 2026 really pulled back the curtain on this new reality. The traditional time frame for a cyber attack is collapsing. Hackers used to need weeks to probe a network. Now AI is reducing that attack time to mere minutes.
The examples from the Black Hat Conference are wild. Think about the smart devices sitting in your home right now. The security experts set up their own network from scratch at the event and watched it get attacked by thousands of the world's best hackers simultaneously.
It was a live battlefield.
Yeah. They saw people using a generic weather app that was secretly leaking their exact GPS coordinates. Someone's automatic cat feeder app was vulnerable to being completely hijacked remotely.
It sounds trivial, a cat feeder. But it highlights the core issue. Basically, every connected device is a potential entry point into your home network or a corporate system.
And if the attacks are happening in minutes, human security teams can't possibly type fast enough to stop them, so the defenders have to fight fire with fire. The network team at Black Hat built a whole stack of AI defense tools just to survive the conference.
Exactly. AI is becoming the only viable defense against AI speed attacks. They deployed an AI chatbot named Trevor that allows the security team to type natural language questions and instantly get complex database code to track anomalies.
But the most fascinating tool they used was machine learning to monitor something called beacons. What exactly is a beacon, and why is it so hard to find?
A beacon is a tiny, regular, almost invisible signal. When a device is compromised by a hacker, it doesn't always steal data right away. Often it just quietly installs itself and sends these little check-ins back to the attacker's server. Just a tiny whisper saying, "I'm still here waiting for instructions."
Like a digital heartbeat.
Yes. And because there is so much normal background noise on the internet, your phone checking for emails, your smart TV updating those tiny malicious heartbeats are nearly impossible for a human to spot.
Makes sense.
But an AI can monitor millions of normal connections simultaneously and spot that one strange metronomic pattern hiding in the noise.
And that is exactly how the AI caught a real-world attack during the conference. The AI agent mapped the behavior of every device on the network and flagged a laptop belonging to a Taiwanese journalist.
Right.
It was infected with malware, making these tiny beacon connections hidden in the regular traffic. The AI traced it, checked network clues against internet data, identified the owner, and the traffic ultimately traced back to servers in China.
It is a perfect, contained example of the new global battlefield. AI-powered attacks are intensifying, and the only way to catch them is with equally advanced defensive AI mapping the network in real time.
But hold on, let's connect all these dots together. Anthropic is voluntarily holding back their best product, Mythos, because they spent the money to test it and realized it's too good at hacking. Meanwhile, DeepSeek is strapped for cash, desperate for hardware efficiency, and completely ignoring safety testing in their documents. In a year where everyone is desperate for an edge to survive the compute crunch, isn't Anthropic's good guy restraint actually a massive business disadvantage?
That is the core, terrifying dilemma of 2026. If you are a responsible lab, you spend millions of dollars testing for safety and holding back your most powerful features. That means you lose market share to competitors who don't care.
Right.
But if a lab lacking that restraint releases a cheap model with the hacking skills of a Mythos, the entire global cybersecurity landscape shifts overnight.
So it essentially becomes a race to the bottom. If you want to survive the brutal economics of the hardware monopoly, you literally cannot afford the luxury of being safe.
Precisely. We are entering a highly turbulent transitional period. The economic pressure from the top, from the hardware costs, is forcing the safety guardrails off at the bottom. If sensitive corporate and personal data keeps flowing into these insecure AI systems and threat actors get cheap access to unrestricted models, well, the sheer volume of breaches is going to skyrocket.
So let's step back and look at the whole picture we've explored today. We live in a world where physical processing power is bottlenecked. Hardware monopolies like NVIDIA and TSMC are extracting all the profit because they control the physical infrastructure.
Yeah.
Geopolitics is forcing companies, like those in China, into massive inefficiencies and state-mandated detours. And because of that sheer economic desperation to stay alive, basic safety limits are being completely ignored.
The metric for success has fundamentally changed. It is no longer a question of, are you using AI? Everyone is using it. The question every company has to ask themselves now is, are you using AI efficiently enough to survive? Because if you aren't, the compute costs alone will bankrupt you.
It's a sobering reality check. But we want to leave you with one final chilling thought, straight from the floor of the Black Hat Cybersecurity Conference. A security expert there noted that the vulnerabilities discovered by AI today, the cat feeders, the weather apps, are just the warm-up. He said that in just 1 year, there will be a new AI model that makes today's terrifying hacking AIs look like a toddler with a keyboard.
A toddler with a keyboard. I mean, if today's AI can crack a network in minutes, imagine what the adult version will do.
Think about all the smart devices sitting in your home right now. If the entities holding the most powerful compute decide that safety is a luxury they can no longer afford, who is going to build the AI that defends us?